Hey guys, Joe Pye here. Welcome back to my shop. You know, with all of the crank arm linkage, all the gears, everything needed to make this piece go back and forth, we need to do something to tie this to that. And that's all this little stuff right here. So I think that's where we're going to go next. First piece I'm going to do is part number 18. And that is called, well, it's just part of the ram linkage. It's made out of brass. It's 1/4 inch in square. And that's a 540 thread through it and on top. I'm going to set that up in a vise. I'm going to do the cross hole and the slot and this hole first and put it in a collet, and we'll turn and thread this on the lathe. Let's do it. Next piece in line, number 45. It's the link. Not a very complex part, but it does present a couple of holding difficulties if you want to do it all at one time. I think you're going to like the way I do it. Let's take a look. To do this little part, I'm going to make some more soft jaws. You've seen me do this before on the other projects, but I'm going to do this a little differently because I want to hold the part a little differently. I want to machine these so that when they're machined, they're just a little bit below the surface of this vise. I'm going to do that by using feeler gauges. One's 22. If we can get a closer look at that. It was there a minute ago. There you go. 22 on top. This one. I'm going to put that underneath the parts. Let's torque down on them now. Okay, by doing what I just did, I'd effectively know that this surface right here, when I pull that parallel out, is going to move down 22 thousandths of an inch. I'm going to take the 20, and I'm going to set the height of the cutter I'm going to use to deck these off with the 20. So when this is done, it'll be 20 thousandths above this surface. Open the vise, pull the shim. The top surface will now drop to 2 thousandths below this surface. Easiest way I know how to do it. Yeah, if you know of an easier way, by all means put it in the comment line. That'd be great. I am not touching that shim right now because if you bring an end mill down onto the top of a rigid surface, you have a good chance of blowing the corners off of it. So don't do that. I'm going to come up with the table slowly but surely, moving the shim in until it's snug. There we go. That cutter is now 20 thousandths above this surface right here. This will make a whole lot of sense here in a minute. Stick around. And for anybody that's going to leave a comment that, hey, why didn't you just do that with a larger diameter cutter and do it in one shot? Well, I didn't feel like it, that's why. And this is not an extremely high pressure vise, so I didn't want to take the chance of this thing sliding to and fro. All right, top of this is now 20 thousandths off of here because you saw me set the tool. Let's pull out the 22 shim on the bottom. And I will remove these and deburr them, but just for sake of demonstration, at this point, let's pull the shim. There you go. The surface of these two parts is now 2 thousandths below this surface right here, and you can trust that. Now that's important in an upcoming shot, so bear with me for a second. I got to cut a little piece of material to squeeze in there. I'll be right back. After a little deburring on the surfaces I just cut, I'm going to put them back in. Open the vise. A little bit thicker than the part I'm going to stick in there. This is the part I'm going to stick in there, but I have to drill through it, so parallels are kind of out of the question. I could put a step in these jaws. You've seen me do that before, but I'm going to do this a little differently. Magnet. Doesn't get much easier now, right? It is now level with the top and front and rear jaws. These are out of the way. It should be straight. And as I close it up, the magnet slides. All is well. The reason these are lower than the jaws is so that it doesn't pop open if the pressure is above the clamping surface. You only need a couple thousandths of an inch, so there you go. I'm going to squash down on it. Oh, take that out. Now I have a part that's sitting in there perfectly flat and level. I can access both ends. I can drill the through holes. And then we'll have to worry about the end radiuses. Probably do it on a sander if you wanted to. Maybe I'll do it on the rotary table since this vise is already on the rotary table. Let's do it. Just so nobody is left scratching their head with exactly how I'm going to cut this piece without using any measuring equipment or indicators or edge finders, let's take a look at the part itself. This is the small piece that's in the vise, or will be in the vise, or it may already have been in the vise because I'm shooting this out of sequence. And these are the small aluminum jaws on either side of the part. Okay, aluminum jaws on either side of the part. There's the part. Once I put the part in and I got a position with a magnet, I know that it's flat. Well, I also know that it's an oversize in length. So when I come in and I hit that part with my end mill, I'm going to put a 0 on my digital. Now, if you don't have a digital, then put a 0 on your dial. So right now, let's call this X0. When I move over to this side and I touch it, let's say this is now X600, for lack of a better term. I know that X300 is right in the middle of this part. Now the centerline feature on a digital readout, when you hit a 0 and you come over and you have a second function or a second value show up, then you hit the center line and it automatically zeroes this point out for you. So if you didn't have a centerline feature on your digital, well, crank it back to half of what you've got, and now you have your 0 or the 300 point in the part. That is the center of the blank along the x-axis, not the y-axis. Now, since I had aluminum nests in the jaws, I was able to take a bump and a bump, bump and a bump. Let's just say the bump here is 0, and the bump here is 100. Well, I come back to 50. I could also use the centerline feature for the y-axis, which now makes this 0. And there we go. The center of the part is now located without ever having touched a piece of measuring equipment. Now, by knowing the center and by knowing the radius of the part, I'm actually going to draw on this. Look at that. You take the overall length of the part, which is here, half the part plus half the cutter. And these are your new values. And when you make the cuts, the part will be to print. Additionally, with your 0, 0 having been determined by bumping the nests and bumping the end of the part, not only is the part to length once you know the diameter of your cutter, but you can use this location here as the central location for the offset for the 2 holes. And since it's suspended between 2 aluminum blocks, you don't have to worry about encountering any parallels below the part. So if you don't have a sacrificial piece of aluminum or something under this you can drill into, the magnet gave you the flat and the aluminum gives you the ability to saw the ends off, cut the ends off, mill the ends off to length. All right, now that everybody is completely confused, you can roll that back and look at it again. Bump, bump, center. Bump, bump, center. 0, 0. Mill, mill. Drill. Done. Camera is now behind the machine on the left-hand side, so I'll be standing on this side of the cutter. What I'm going to do is take this cutter, I'm going to bump each end, I'm going to set a number, I'm going to come over here and bump that one, hit the center line feature on my digital, that'll give me the middle. Knowing the diameter of the cutter, I can offset equally and come up with the overall length of the part based on the diameter of the cutter. So I'll add the radius both ways, or half the overall length both ways, plus the radius of the cutter for my offset to give me the length. I'll probably do the same thing for the inside. Just touch the jaws front and rear with the cutter, zero out, find the center line, and complete the part without ever measuring it or touching anything. Just cut the part. Overall length of the part is complete. I'm going to bump the insides of the jaws to set my y-axis 0. And that'll give me the center line for the drilled holes. And yes, you could stick an edge finder in there, you could stick an indicator in there, but this is a link, and I'm going to trust the chips that come off of this because there's no relief in the jaws. I know right where that center is. Now, I was asked just recently about the speed differential between drilling and reaming. And for the record, when I'm on the mill and I've just drilled a hole, all I do is throw my machine into low gear to ream it. I don't mess with the speed range at all. It's worked really well for a long time. I'm not going to change my technique now. So no speed differential on the dial, just going into low gear for this. On the lathe, I usually cut the speed in half. It's just easier on the high-low on the mill. Next piece in line, number 19. The little ram handle that controls the stroke of the ram. Initially it looks like a scary little part, but I got a plan. I think this is going to go pretty easy. Let's check it out.